All right, so here is the second type of connected object problem. So this is what we call a modified Atwood machine. It has the same look as an Atwood machine, but the only difference is now you have a table, right? One of the masses is on a table. But again, draw, sum, solve. And very typical of these questions is always going to ask for the acceleration and the tension, okay? The thing is, block A will accelerate at the same rate that block B accelerates, okay? So suppose you have a hanging 1 kilogram lab mass attached to a 4 kilogram block on a table. The coefficient of friction between the block and the table is 0.20. What are the acceleration of the system and the tension in the string? Okay, I'm going to do my diagrams over here. So I got FG down, right? I have the tension. I have FN up. And with this one, I have a friction. Here, I'm just going to have FG down and T up, okay? Not FT, but T up, okay? So we're going to assume the positive direction is going to be to the right and positive is going to be up, which for our block or our mass of B, it's going to put the positive X down and the positive Y to the right, okay? And now I'm going to sum the forces. So I'm going to sum the forces for block A, okay? And I'm going to sum it for, so this would be A, and this would be B, okay? And so sum of the forces in the Y direction is equal to 0. So I have Fn minus Fg equals 0. Fn equals Fg, which equals mg. Typical, right? It's a block on a table. That's how you treat the Y direction. Okay, the X direction, you're going to have the sum of the forces in the X direction is equal to MA. And so I'm going to have tension positive, friction negative is going to be equal to MA. Okay, so I'm going to have T equals negative mu Fn equals MA. Right, and then T minus mu Mg equals MA, and I'm going to solve this for T, right? So it's going to be MA plus mu Mg. I'm going to solve that for T because I'm going to use a different systems of equation technique, right, than I did in the previous video. So here, I'm going to have the sum of the forces is equal to MA, right? And so I'm going to have positive Fg. I know it's weird that the weight is positive, but by our coordinate system, it is positive. And we have Fg minus T equals MA. Okay, and then so it's going to be Mg, and you can put subscripts here, 2, 1, or A, B, right? And these are going to be ones. So minus T equals M2A. Okay, solve this for T by adding T over, subtracting M2 over. So it's going to be T equals M2G minus M2A. Now the technique is I have two equations, both solved for the same variable. I can set them equal to each other. And so I'm going to have, let's see, M1A plus mu Mg equals M2G minus M2A. Right? I'm going to get G's to one side, A's to the other. So I'm going to add M2A over. So M1. I'm going to do once I'm going to factor. Oh, look at that. Total mass, right? I told you the signature is total mass, right? And then I'm going to subtract. So I'm going to have M2G minus mu M1G. Okay? And now to solve for acceleration, I'm going to say A equals M2. And I'm going to clean this up a little bit, right? So let me erase. So we're going to do, let's see, it's going to be G times M2 minus mu M1 over our total mass, M1 plus M2. And now I just plug in, right? So A equals 10 times 1 minus 4 over 1 plus 4. Okay, so now we're just, we're plugging in values. So this is going to be 1 minus 0.2 times 4, right? There's our total mass, right? Remember, signature of an Atwood machine, whether it be modified or regular, is we're going to divide by total mass. Okay, and so we're going to say A equals, okay, so it's going to be 10 times 1 minus 0.2 times 4, which is 0.8. 1 minus 0.8 is 0.2. 0.2 times 10 is 2. So we have 2 over 5, and so our acceleration is going to be 0.40 meters per second squared. Now, sometimes you may doubt yourself and say, how can a 1 kilogram object accelerate a 5 kilogram object? It's because it also has the weight, right? It has gravity acting on its side, where the 4 kilogram object doesn't. Okay. Now we're going to take that 0.40 and plug it into one of our tension equations. I'll just plug it over here over on the block 1 side. So it's going to be 4 times 0.4 plus 0.2 times 4 times 10. Okay, and that's going to be 4 times 0.4 plus 0.2 times 4 times 10, and that's going to be a tension of 9.6 newtons. Okay, that'll be our tension. All right. Now the next video is going to do an Atwood machine, but it's going to be on an incline. So we're going to see how incline affects it.